Hello viewers, welcome back to another section of my YouTube channel tutorial. In this video, I'm going to take you through Newton's Law of Gravitation. This is an interesting law in the field of physics and it has been useful at the cosmic level. Now let's delve into what the law entails, the formulas which are related to this law, and some little application. Please, if it is the first time you are visiting this channel, kindly subscribe to support. Please watch the video to the end so you understand every part of this video. Now let's state this with this law. So the law is saying that for any two bodies, for any two bodies which are separated, so separated by a distance r, separated by a distance r, the force of attraction, the force of attraction between them is proportional to the product of their masses and inversely proportional to the square of the separation. So now let's see. Newton is saying that for any two bodies separated at a distance r in this universe, there is a force of attraction between them, and that force has a magnitude which is proportional to the product of their masses and inversely proportional to the square of the separation. Mathematically, it is F is equal to capital G m on r squared. So this is the mathematical representation of Newton's gravitational law. Now let's see. What this law is saying is that if I have a body A, I have another body B in the universe, any two bodies in this universe, provided they are separated by a distance r, then there is a force of attraction between this body, and that force of attraction is equivalent or is proportional to the product of their masses and inversely proportional to the whole square of the distance between them. From this, we can see that whenever two people get close together, or whenever any two bodies are into consideration, there is a particular force of attraction. Now, take note, that force of attraction is dependent on the product of their masses, meaning if the bodies are not huge enough, then that force of attraction wouldn't be significant. And that is why most bodies we see around, when they are placed side by side or when they are considered as a pair, the force of attraction between them is very small because the masses of the bodies are too small for the attraction here to be significant. Let's consider the moon and the sun. The moon and the sun, they are very huge bodies, and because of their masses, the force of attraction between them is very significant and very strong to pull them and maintain their position. Now let's talk about the distance. So he said it is inversely proportional to the square of the distance. Once there is an inverse relation, the smaller the distance, the higher the force will be, right? For that reason, if two bodies are closer together, then it means the expected force of attraction should be higher. But when they are far separated, then the force of attraction will be smaller. So assuming you have a person standing here, you have another person standing here. When I consider these two people, there should be a force of attraction between them. But because their sizes are so small, the force is insignificant. The distance to is also a factor. But when you go to the celestial level where the huge moon, the huge sun, and the huge celestial bodies are into consideration, the force of attraction will become significant. And that is the main reason why the sun and the moon are in place together and they are hanging without falling because the force of attraction between them is so strong to keep them in their position. Now, let's talk about the parameters. You can see G here. G here is what we call the gravitational constant or constant of gravitation. Constant of gravitation. And it has a value. So G is equal to 6.673 times 10 to the power negative 11 meter cube per kilogram second squared. This is the value for the constant you see. So that the product, and these are the different masses. So this is the mass of one body, and this is the mass of the different body, and this is the r squared. But there should be a constant here, and that constant is given by 6.673 times 10 to the power negative 11, and it's mathematically calculated. So let's see the force exerted by the earth. So now let's consider the earth and a person on in the earth, or let's say an individual, a human being. The earth is a body, human being is a body. Newton is saying that when two bodies are separated at a distance r, and it's true, we are separated at a distance. So when you consider the earth and a body within the earth, the distance between them is going to create a gravitational force. And now that force is what we call weight. So your weight of your body is due to the gravitational interactions with the earth, right? Hence the earth is a huge body and it's going to make the force of gravity significant. And you know at the center of the earth, gravitational force is very high because of the distance nature, and the earth has a flat top, not giving it a uniform spherical nature. So if you stand at the center, the distance becomes relatively smaller, and hence the gravitational force of attraction becomes higher. So that is interaction and what we call the weight of the body. So weight is equal to what? Mg. Now it's from the Newton's law of gravitation. As we know, F is equal to g m over r squared. If I take u as your m, and I take this m as the mass of the earth, I can multiply the g by the mass of the earth, which is known, over the r squared, and this becomes what we call the acceleration due to gravity. So this is a constant which has been calculated, and now we are using this as what? G. So you know that G is equal to Gm on r squared. Hence, the weight of the body is what? Mg. Because the mass and the G here, which should have been the expression this, has already been simplified. Thank you for watching this video. Hope you got everything I taught in the video. Please subscribe, you share, and you like to your friends.